Hello, good morning, testing, testing. Hello, sound, sound, sound. I think this is good, right? Uh-huh. Okay, oh, wait, the lights. I need to turn on the lights. Wait. Am I showing my belly? Oh, yeah, a little bit of my belly. Okay, alrighty. And are we ready? 1, 2, 3. Good morning, or good afternoon, or good evening, whatever you're calling from, whatever in the world this video might find you. How is it going? Andres, hola, ¿cómo andas? Arasto, good morning. No, good evening for you. How are you doing? I'm very happy to be back. I'm glad to be back. What time is it? Yes. Um, it's been a while, huh? It's been quite a while. So, I have been, as many of you know, I have been a little busy these last 2 months, I think. And I have, unfortunately and very regretfully, I have neglected a little bit of the work that we were doing here because I just couldn't keep up with everything that I had to do. But it's for good reasons, I guess. But good news is that everything that had to be done has been done, and now I'm back, and I think I'm gonna actually have quite some time this summer to focus and concentrate again on the work that we do here. So I think I'm going to be streaming again consistently, and actually I have some plans on how to do that. So that should be good. Hey, Rafael, how are you doing? Welcome again. So yes. So what's going to happen? I think today we're gonna take it a little easy because it's been a while. I feel kind of rusted. I have not done this in a while, and I'm a little like, oh, what's going on? and and then I'm gonna get to that in a second, Arasto. So, and then what we're going to do is today I'm just going to record like 2 or 3 small videos of C sharp topics the C sharp topics that I wanted to talk about, but that didn't really make it to the main learning C sharp for designers list. So I'm just gonna record them. I'm gonna put them in the end, and then those can be helpful. And if at some point in the future I decide to make a more advanced list, then we can move those videos to the advanced list, or we can record it again, or I don't know. But it's just for me. I think those videos are just going to be like a small way for me to get rolling again. And then there's not going to be a live stream this afternoon, but also I'm thinking of what is going to happen next. So, Hamidreza, welcome. Chandra, how you doing, sir? So, as Arasto is saying, I'm actually looking for ideas of new playlists to record. So, what I want to do is I want to finish the introduction to parametric modeling playlist that I started a while ago and I never got back. So I want to finish that, but I think I'm actually going to do it in an intense way. So I think I can block a week, not next week, but I think the week after that, I can block it entirely to just record videos. So I think what I'm going to do is during that week, every day of the week, I'm going to do 2 live streams, and I'm just going to like crack down like grasshopper, toon, 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 until we get the list done, and then we can move on to other topics. I think this is going to be useful because if I don't do it that way, it's probably never going to happen because it's going to be a fairly long playlist, and I have some time to do it. So I think that's going to be the goal. So you can expect that the week of what is it going to be? The week of the 19th. Yes, the week of the 19th of May. that week I'm going to be streaming every day, twice. And just like grasshopper, grasshopper, grasshopper until we complete the list. And then I am thinking of what is going to be next. So I had a couple ideas. I want to do a playlist on Git and what is Git, how do we use it, how do we install it, what is the relation to GitHub, how do we make pull requests, commits, and all that kind of stuff, and make it work collaboratively. And then how to do that for file types that we commonly use, like Grasshopper ones. I want to do something like that. I think I also want to do a playlist specifically on C# programming within Grasshopper. So I think that playlist would be something like teaching you, assuming that you know how to write C# because you've watched the other playlists, assuming that you know that, how do you write code inside of a C# script component, taking a look at Rhino Common as a framework, and then moving on into how do we write our own compiled Grasshopper components, and therefore how we could create a small plugin for Rhino. That could be another playlist, super interesting, but I'm actually open to suggestions. So if you're listening to this right now and you want to write on the chat, or you want to put it in the comments of the video, I would rather you do it in the chat right now. But if you have some ideas of topics for a playlist that you would like to see, I'd be more than happy to listen to those. Also, you're more than welcome to do that in our Discord channel, because I don't know if you're new to this channel, you may not know that we have a Discord server where we keep conversations going throughout the week. So for example, I'm going to paste the link here on the chat. This is the link to the Discord server that we're running. So if you wanna join us for the conversation, and like we have a bunch of channels, Grasshopper, C#, Python, we even have Python. And then on top of that, if you want to be up to date with when do we stream, we're already active on social media. So I typically post stories and stuff on our Instagram and on our Twitter about when do we go live. But the best way is probably to subscribe to this channel. So if you haven't, please just hit subscribe and put notifications. That's the best way to know when we're going live. But also we have a Google Calendar that you can subscribe to in case you want to be up to date. So I'm just going to copy the Google Calendar link on the chat, and you can know when we're going live. I see a machine learning playlist session. I might do some of that, but honestly, I think there are many other more fundamental topics that I would like to cover before we get into machine learning, which is kind of like a next level kind of thing. And also, I don't know if you are familiar with this, so I'm just going to share my screen here. I don't know if you are familiar with, oops, not this. I don't know if you are familiar with the work of Nono Martinez Alonso, but well, he's a good and long time personal friend of mine. But on his channel, he has the videos that he posts for the Getting Simple podcast, so a set of interviews that he does for people and how they work and how they live. But also he has a lot of live streams that tackle specifically tons of machine learning topics for designers, like how to train models, how to create a data set, why machine learning is so and so, how to use Runway. So if you want to get your learning machine learning, yeah, I think I would definitely recommend. Are you seeing? Yes, I would definitely recommend Nono's excuse me. Wow. I would definitely recommend Nono's YouTube channel for you to check out because it's really, really nice and his work is amazing. So, and he does a lot of stuff on machine learning. So, so check it out. Yes. Arasto, point cloud manipulations. What do you mean by point cloud manipulations? What does that mean? We have a point cloud, and what kind of manipulations can we do with a point cloud? I wonder. I wonder if instead of a playlist, that's just more like a series of geometry jams or exercises or that kind of stuff. Maybe, I don't know. Just put it in the chat. I'm happy to talk about that. Victor, VR and MR. I like those topics. It's just that I find it complicated to do as a live stream because like you should see my setup. I have like 4 screens right now, and I have 2 keyboards and another laptop and a set of lights. And if on top of that I need to put on my VR headset and like and all of that, it could be a nightmare. I honestly don't know how I could handle all that technology and then stream it in real time. That could be something serious. Chandra, Unity. Unity is a pretty good topic. We could definitely write a small playlist or a large playlist on Unity. I wonder if there's any particular, because there's a lot of Unity work out there, a lot of Unity tutorials. I wonder if we could find more of like an angle or like some kind of theme in general when teaching Unity. So like, I don't know, Unity for 3D visualization or Unity for interactive art or Unity for something like that. I wonder if there's something that so that we could be a bit more specific, because otherwise covering all Unity is just like it's a lot. And honestly, I'm not such an expert in Unity myself. So that could be Victor, point cloud to mesh. Ooh, that's a good one. But that's almost a PhD worthy topic. Which was, by the way, was not my PhD. But there are tricks. I wonder if that's also something that we could do as a geometry gem. I don't know. Hey, Salvador, good morning. Creating meshes out of it, extracting textures, don't know, like noise reduction, depth to the image mapping. Yeah, we could do stuff. WebSockets 2.0, Salvador, what does that mean? What did we not cover on version 1? You want to do more Python, huh? That's what I see. I see you, Salvador. And then what else do we have? Do you have a personal preference between Unity and Unreal? That's a good question, Victor. I kind of like Unity better. I think it's simpler. It's easier to start with. I think Unreal has a bit more of a steep learning curve. I also like that Unity is based on C#, whereas Unreal is based on C++, which is great, but C++ sometimes is a bit more difficult to me. I don't know. I relate better to C#. I don't know why. I think it's just, I don't know. So there's some things that are, but I think Unreal, when it comes to graphics and when it comes to power, it's a little better. I don't know. I might be starting a personal project on Unreal very soon. So I might be able to, I don't know, take what I'm saying and take it back and change it. I don't know. I have no idea. Carlo, hey, welcome from Italy. Oh, and thank you. I'm happy that my videos helped you. If you did anything cool with WebSockets, share it here or join our Discord channel. You can see the link up in the chat. Join our Discord channel. We have a channel called Work Sharing, and feel free to post what you did there. I'll be more than happy to check it out. I like it when people make cool stuff out of what they've learned in this channel. Okie dokie. What else? Taufik, how you doing? Hello. Salvador, have a lot of fun with WebSockets. Yeah, that was a fun playlist, I have to say. And it was a lot of fun when I was doing stuff and you guys were hacking me while I was doing it. And that was very interesting. Rafael, oh, wave function collapse. I like that a lot. I wonder what can we do with that? I wonder if some kind of like really crazy 3D geometry procedural generation something something. It's so wave function collapse is advanced, is pretty advanced to implement it from scratch. But if we use the library that is out there, which is C# based anyway, I think we could get away very far. So that we could do. Physics simulation, Andres. That's kind of an interesting topic too, now that you're saying. Physics simulation. Like we could do our own physics simulation, kind of. So it's basically like, instead of using Kangaroo, like write our own Kangaroo, our own engine. That could be interesting. That's a good one, Andres. Hey, Kartik, long time no see. How you doing? Yeah. New programming languages. We could also do that. But I wonder what's the other programming language you want to learn, Chandra? Are you going to tell me Python? Python. Finite element analysis. We could do some of that. I wonder. How could we do something interesting? I'm going to keep, yeah, these are really good ideas, by the way, folks. Thank you, Hamidreza. Monoceros for wave function collapse is open source and also have a GitHub repo. Very interesting. Yes, yeah. There is some, I don't know, there's one GitHub repo that has all the code and examples and forks for other languages. It's very popular. Is it possible to make a Grasshopper-like plugin for Blender? That's probably possible. It's just that it would take a lot of time. I think there's something like that. I think, doesn't it have like a Russian name on it? Like, I'm probably not. Like, I think there is like a visual programming environment for Blender. No? Yeah. Oh, Kartik, I'm sorry to hear that. I hope you're doing better now. Chandra, did you say Python? Did you say Python? Do you know what we think about Python here, right? I think maybe you and Salvador should start your own channel. Carlo, oh my God, what do I think with C# versus Python? Oh my God, where do I start with that? Yes, Vershok, exactly. Ah, I didn't know Vershok was Russian for grasshopper. Ah, interesting. Huh. Hey, Arasto, so would you mind that list of ideas, the topic ideas? Would you mind doing that in the Discord server? If you go to the topic suggestions channel, maybe you can start a thread there, and then you can pin it to the channel so that it stays on the top, and then we can use that to conversation. Actually, you know what, Salvador? We could probably do like an intro to C++. That would be interesting, and I would definitely be more excited to doing that than doing C++ and doing Python. Maybe a poll. Okay, yeah, that could be cool. Arasto, please go ahead and do that. You're in charge now. But remember to add the introduction to parametric modeling, which we're going to finish very soon, and the C# programming for Grasshopper, which I also want to do. I think I'm going to do those anyway at some point soon. But the physics simulation idea, that sounds pretty cool. And it could be inspired, honestly, it could be inspired by the work that Dan Schiffman is doing in the nature of code. So we could actually take some of the structure and the example that he uses and then just write them in C sharp. Do it that way, or maybe do it like or create a C sharp library that could be loaded into plugins and that kind of stuff. That could be interesting. R. I have never used R yet, so I don't think I would be in a good position to teach any of that yet. Java. But Java, well, we could do Java. I mean, Java is it's very similar. It's very, very similar to C sharp in many ways. I think at this point, I'd rather just build things. You know, my favorite programming language to teach would be JavaScript, actually. That would be super cool. And writing JavaScript libraries and doing web stuff in 3D. Oh, 3JS? What about 3JS? Or no, or better yet, like WebGL from scratch. That would be really cool. We could do WebGL from scratch. We could do shaders from scratch. We could do a lot of that. Okay, so Arasto. Well, actually, Arasto, it is. People are kind of moving on, but it's still very, very popular, and there's tons and tons of things there still out there in the world that are built on top of Java. I think WebGL. I would love to make a WebGL or an OpenGL, for the same matter, an OpenGL sort of playlist. That would be super, super interesting, actually. Okay, well, shall we get busy? Because otherwise, I'm not gonna record. If we keep chatting, I'm not gonna record any video today. So what are we doing today? Oh yes, we were doing like a couple of small C# videos, which we're going to do enums, we're going to do 2D arrays, and we're going to do functions with the out parameter. Okay, because I didn't get to cover those on the main playlist. So I'm going to switch here, and then we're going to start. So yes. And also, Salvador, now that you're here, I saw your example. I need to take a look at that, but I definitely want to record that WebSocket video, the WebSocket server in Python that we still have pending. So that's going to happen at some point soon. Okay, I don't know. It will probably not happen today, but it will happen sometime very soon. Okay. Now, all right. So let me fire some Visual Studio, and what are we going to do? We're going to create a new project, which is going to be a console application in C#, and then it's going to be something probably going to be in the desktop somewhere. And what am I going to call it? I'm going to call it 61. What is it going to be? Enums. All right. And it's going to be 4.5. Fine. Okay, and then okay, so the first video we're going to do is we're going to do enums. So I'm gonna need a few minutes to think about how to structure and how to say this, and where are we going to start with the code. So enums, for those of you who don't know, are basically lists, like named lists of typically integers, but it can be other things, that we just use as let me see what the official enumeration types. Okay, it's a value type defined by a set of named constant of the underlying integral numeric type. Oh god, that's quite a mouthful. How can we say this in a more English plain way? So imagine you have like you're working with a list of, I don't know, you have like, I need to find a good example to make in the video. So imagine you are classifying objects, and there's like 4 categories for those objects. For example, objects that are blue, black, green, and red, for example. And it turns out that instead of classifying, is that a good example? Instead of classifying them, you need a way to, like, in memory, classify them as one of those 4 categories. In memory, storing strings is very expensive. So you probably want to think, well, let me just say that black is going to be 0, red is going to be 1, green is going to be 2, and blue is going to be 3 as integers. And then you keep those numbers as the numbers that you use for storing in memory. But when it comes to programming, remembering those things can lead to errors. So that's why very often when we want to do those things, we use this structure called enumeration types, so that we can give names to those constants, so that it's easier when we're programming to refer to this object is of the type green, even though in memory that gets stored as the number 2, which is very cheap. So is there a better way of explaining that? And also, what kind of example could I write to illustrate this idea? Enumeration types explained. Example. Enumerated types. Oh. Enumeration types. These could be the status of a package. Marcelo. That could be a good call, Marcelo. Thank you. Maybe we might use that. The status of a package. The status of something. Okay. Okay, so then what could we build? What could the example look like? So enum status, and then, for example, departed on traveling delivered, for example. And then what for an example we could have here? I wonder if I should be like a small class. I wonder if I should build a small class so that we can because if I do it now, then I do console read key, and I do this and delivered and maybe I could just say we're writing a program, package tracking program, and then here we say int status package status equals 0. And then we say, I wonder, I would like to write some code that makes this look a little cleaner, and then so that we can change this. Oh, maybe, wait, all right. Okay, so if package status equals 0, then console write line package is on its way. Hasn't left facility. And then else if package status equals 1. Oops. And then console write line package is on its way. Else if package status equals 2. Console write line package is delivered. And then console write line package status is then package status. This could be decent boilerplate. I need to take a tiny break. I'll be right back. 1 minute. I'll be right back. Alrighty. So where were we? Yes. All right, we have this. I think I can explain now that we typically have, it's very common to have a way of needing to know the state of things between a set of discrete options. Yes, that's a very common thing. So we have a set of discrete options, and then what we just want is to make decisions based on that. And we typically use integers for that. So I explain that, and then I go here to enumeration types. I explain what they are, and then I implement them here. And then I discuss the problem of like, this makes things much more flexible because we don't have to care about numbers, we just care about the names, and we are flexible, we can move things around. So I think this is a good way. Marcelo, or Marcelo, I'm not sure how to pronounce that. Thanks a lot. That was a good idea. So let's get started. Woohoo! It's the first video that I record in more than a month, I think. This is bad, but we're back on track, okay? All right. Woo-hoo-hoo. Let's do this. 1, 2, 3. Hi, this is Jose Luis, and in this video I would like to teach you what enumeration types or blah, 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 blah. Starting over. Hi, this is Jose Luis, and in this video I would like to teach you what enumeration types are in C# or enums for short, okay? And the basic idea is actually quite simple. And I have written some code here that I would like to use to illustrate when are enums actually pretty useful. So imagine that we are writing some kind of, imagine we work for a large retail online store of some kind. You probably know what I'm thinking about right now. And we're writing some kind of software that is trying to track the status of a particular package going to your place, okay? And there are discrete different statuses that the package can have. It might be still in the warehouse. It might be on its way, flying to your house. It might be out for delivery, or it might already be shipped. Okay, so all of those are possible different states. Now, how do we represent those states in memory in our program with variables? Well, very typically, instead of keeping a string as a variable that says shipped for delivery or blah, 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 keeping strings is fairly expensive memory-wise, but also comparing them and saying if the string is shipped or if the string is out for delivery, that is also a pretty expensive comparison, computationally speaking. So a very common way of doing this used to be using integers, because since we know that there are a set of different discrete options, like for example 5 different options of how a package might be status-wise, then we can represent those with numbers that go from 0 to 4. And if the status equals 0, we know it's out for delivery. If the status is 1, we know it's already shipped, whatever that is, right? And then we can make decisions based on that. So for example, I have a very simple program here that when I run, it figures out first, it prints to the console the number that we have used to represent the package status, all right? And then I have a set of if else that checks the value of this variable, package status, and if it's 0, it prints a message that it hasn't left facilities, or the package is on its way, or the package is delivered for 0, 1, or 2. Okay, so this is great. It's fine. This works. Now, the problem with this is that for large programs or for teams of people who might not be familiar with the convention that we're using for representing numbers and status, this can be confusing and this can lead to a lot of errors. Because if, for example, I forget what 0, 1, or 2 means, then I might write code that is not working correctly according to that convention. But also, if I want to extend things, say for example that I have 3 status, it hasn't left the facilities, the package is traveling, but I forgot to add another situation where the package is out for delivery. So because I'm already using the number 2 for when the package is delivered, I kind of cannot insert it between 1 and 3, but then creating an else if, that is, if package status is 3 is out for delivery, it's kind of counterintuitive because it feels that it should be before 2, which is like the end of the package being delivered. So it can be a little confusing and it can lead to errors. So that's why in C# and in many other programming languages, we have this structure called enumeration types. And enumeration types is basically a way of saying, a way of creating a set of constants that have a particular name and that represent internally, underlying, they represent just integer numbers, but the way we use them, we read them and we compare them is by their constant name, which for us humans makes things much easier because instead of the value of 0 being still not shipped, I can just write this still has not shipped as a constant thing, right? And then that comparison is much easier to read, much easier to write, and then we don't really care about which number is underlying that. Let me show you an example of that. So for example, I'm going to write here outside of the function, inside of the class, I'm going to write here a new enumeration type, which is going to be called, for example, status. All right. And you can see that I'm using the enum keyword and that I am writing here the word that I choose for the category, the general type of things. And then inside, I'm going to write all the possible statuses that my package can have. So for example, so I'm going to say the first one is going to be in store. The second one is going to be in transit. And the last one is going to be delivered, for example. So my package can only have 3 status. Still in the warehouse, it's on its way to you, and it has been delivered. So it's over. So each one of these actually have a number. You see? So for example, in store, if you see me hovering, you see that number 0 pops up. In transit, number 1 pops up. Deliver, number 2 pops up. But I don't care, because I'm only going to refer to this from now on, not by their number, but by their name. So for example, what I'm going to do here is I'm going to rewrite my program so that it's easier for me to understand and to track what's going on. So first of all, this variable, I'm going to replace it. And now instead of being an integer, it's going to be of the type status, because a status is now a type of things. And then the name is going to be package status. And then I'm going to initialize this to a particular value. You can see that it's already giving me a suggestion, status dot, and you can see that I have 3 possible options: in store, in transit, delivered. So for example, let's say that it is still in store. So it's at the very beginning. So that way you can see that now my package status is a variable of the type status, which I just created here. And the initial value is that it is in the store. And now I can rewrite my conditional statement and say, well, package status, if this equals to status dot in store, then it still hasn't left facilities. Otherwise, if it equals status in transit, then it means it is on its way. And if it is status dot delivered, it means that the package has been delivered here. So now I can run this code, and then it looks like, oh, what did I do here? Okay, sorry. Yes, I moved things around. So yes, so oh, sorry. Deliver. Okay, yes. All right. So you see now the package status printout is not even printing the number anymore. It's printing that it's from the type in store, and package hasn't left facilities. Otherwise, here, for example, if I print delivered, then I can run this, and then the package has been delivered. All right. Okay, cool. And so this not only is easier to read and to write and understand from a human perspective, but it's also much more maintainable. Because if I want to add a new status to my program, the only thing that I need to do is just go here and add, for example, out for delivery. This is a very common one. And I may just want to actually just put it here in the middle. And you can see how immediately the number 2 is not delivered anymore, it's out for delivery. You can see this from the tooltip, and deliver has changed to number 3. But that doesn't matter, because my code doesn't depend on numbers anymore. So I don't need to remember to change them. I only need to remember that their names. So for example, now here in the middle, I can say else if package status equals status out for delivery. So you will receive your package very soon. Okay. And then I can just, for example, here, this is out for delivery. And I'm going to run this code, and yes, I'm going to receive my package very soon. All right. Okay, so this is enumerators. It's just basically, as a summary, it's basically a way of giving names to numbers so that we can use them as a type. And as a type that has a set of discrete different constants inside of it. So for example, here the type is the status, and the possible values that a status can have is in store, in transit, out for delivery, whatever, which is just names that are basically hiding numbers behind of them. Okay? All right. Enums are really useful when we're writing programs and we want to differentiate things by types or by statuses or by different properties that they may have. They're actually pretty useful, and they make writing code much more resilient and much easier for humans. So I really recommend that you give them a try and you check them out, and you implement them in your own programs. Okay? Thank you very much, and see you in the next video. All right, how was that? Was it understandable? Did it make sense? No? What do you think? Any questions about enums? Okay. All right, so what is next? What are we doing next? What are we doing next? I don't know. Oh, here. Yes. So, 2D arrays. Okay, 2D arrays. What could be a good example to write 2D arrays? Well, something that is, it's a screen. It's like the pixels, right? I wonder if we have any of the previous videos, like the ASCII art or something that we could use. Oh, look, we're live. So I wonder if there is any of the ASCII art that we could use here.
I heard about Halo.
Hi, and welcome to. Sorry. Yeah, definitely something like this could be applicable. But I just want to make like a simple piece. I don't want to overcomplicate it with a long example. So what could that be? What could be a good example of needing a two-dimensional array that is not overly complicated and that we can to store multiplication tables, to store the values of multiplication tables. Like first row is multiplication table of number 0, second row is multiplication table of number 1. I don't know. tree of data like Grasshopper trees. The thing with trees is that they don't have the two-dimensional rigid structure. Trees can have one branch can have one element, the second branch can have 17 elements, the third branch can have branches inside of it, so it's a much more sparse structure as opposed to two-dimensional arrays. I'm thinking of just an example where we store a bunch of data. hmm. Uh, I'm thinking of storing like the multiplication table or the powers of a number. Just make a case about, because it's expensive computation, it's easier to have as a 2D array. Or maybe should I just do something graphic? Maybe we could do something graphic. Maybe I could explain it memory-wise, and then we could pause the video, and then I could write a second example where we just draw like a square, and that's the grid of pixels. A labyrinth. Well, I would definitely want to make I would definitely love to make a playlist on labyrinths and mazes. One of my favorite topics in the world. Andres, yes, it is implemented. So enum is not a class. It's two different things. An enum, you can write enums inside of C# in Grasshopper. That's not a problem. Oh, because you cannot write an enum inside of a function. It has to be outside. So I think we're going to do, okay, so let me open a new Visual Studio and then create a new project, and then here, and that's going to be 62 to the arrays. And then C# to the arrays. Multidimensional arrays. And these are jagged arrays. An array of arrays. Yeah, that is different. So this is more like what you're looking at. Arasto, this is what you're looking at, jagged arrays. This is closer to what a tree structure would be in Grasshopper. Yes, Andres. It has to be written outside of the function. So should we do 2D arrays and should we do jagged arrays? Is that going to be confusing? What do we think? I think I want to start simple with 2D arrays and what? Yes. And now, what could be the problem? So we're writing this, and it's very difficult because we have 2D arrays, so I'm blanking out here. You see, this is why I need to get back on the it's been a little too long. I'm kind of rusty with these things. Multi-dimensional arrays. So what could be a good example? Simple C# console application. I'm just going to do the multiplication table. A building mailbox system represents an array. Victor, I like that a lot. Thank you. Yeah, that could be, because one dimension is the floor which you live in, and the second dimension is the apartment, right? So apartment 1, 2, 3. Yeah, and it's not confusing. That's a really good one. Victor, I like it. We're going to do it. Yes, let's do that. And I wonder if we could use that. I wonder if we could use that to also talk about jagged arrays and say, like, I mean, maybe half the building has 3 apartments per floor and the other half has 4. Less different, you know. Huh. So that could be interesting. A penthouse. Yep. The last floor is a penthouse. Okay, so maybe we do that. Okay. All right. So 2D array. I wonder then, maybe 2D arrays is not the right name. Maybe the right name should be multi-dimensional arrays or jagged arrays. Let's stick to 2D arrays because this is a beginner list. So let's stick to 2D and then we can expand farther down. So what would be the example that we would like to do? So what can we store? We can store, is it a list of strings? Is it a list of strings? Or is it where? Apartments, and then it's going to be a new, so that's going to be a new string array of, I don't know, 10 floors and 5 apartments per floor. Simple, will it have mail or not? Okay. So as mail, new boolean 10 5, and we can, and then we can do integer floor count is going to be 10 apartment per floor. We can do floors, apartments per floor is going to be 4 apartments, and then here we use floors. I'm building the example so that I know where I'm going, and then I'm less and then I equals 0. I'm going to call this f. If f equals 0, f is less than floors, f is plus plus. We can do I, y, and then for int j equals 0, j is less than apartments per floor, j plus plus. And then we can say apartments I and j. And this is going to be apartment. How can we're going to store the name of the apartment. The apartment is going to be floor I. Okay, so apartment, and I'm going to do string literals here. I'm going to do apartment I, j, for example. And then boolean, has male is going to be I dot j equals math random. Oh no, there's no random. I have to use random. Oh God. Unit I plus 0 plus j. Could be. I plus 0. Wait. 0 plus j. Okay. I wonder if how can we randomly choose if they have male or not? So, because I don't want to get into the whole math random next generator, etc., etc. Because we haven't seen that really. I wonder if that's another. Should we do like a random? How to generate random numbers? It's actually not very difficult. So, wait, Visual Studio Code. Create a new project. 63 random numbers. And then put male in them. Yeah, but I want to put male in them randomly. So how could we put male in them that is not random, but it's just you're right. Maybe we don't have to get into the whole random business. We can just initialize it to false and then add male. And then, for example, has male 2, 3 equals true. Has male 8.2 equals true, for example. And then console.read key, and then console write line, and this is going to be a reference type, right? Yes. So then I can just write another for loop here and say blah 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 console write line apartments ij, and then has male and then has male.i.j. And this will be apartment, blah, 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 and a list of all the apartments that have male. This could work, no? Maybe. So let's say we have 7 apartments and 3 per floor. This could work, no? Okay. All right. I am going to copy. I'm going to copy this somewhere so that I don't lose it. And I'm going to just put it here on a corner so that I can keep an eye on it. And then yes, okie dokie. And then I'm just going to I'm probably going to start here. Okay, Victor, good job. We got this. And this is going to go somewhere here. Okay. Okay. Okie dokie. Let's do this. Wait. So right now, what we would have Boolean has male floor 0 equals a new Boolean of apartments per floor. So basically, if I wanted to do this right now, I would have to do something like this: 1, 2, 3, 4, 5, and 6. Okay. Yes, I think that's a good way of telling the story. Okay. All right. Hi, this is Jose Luis, and in this video I would like to teach you how to write multi-dimensional arrays in C#. And you may wonder, why do I even need multi-dimensional arrays? What does that even mean? So let's think about what we've learned in the previous videos. We know that arrays are really good structures for storing a list of ordered values. Values that can be numbers, booleans, strings, whatever, one after the other, to which we can refer by the position at which they are on the list. So this is really useful for storing large collections of data in one dimension, meaning we only have one list and the position is basically just in one dimension. This is great for lists of things, but very often you will find yourself in the necessity of storing not only lists of things, but lists of things. So for example, imagine we were writing a system to keep track of the mail that is arriving to a particular large building. A large building that has several floors, and then each floor has several apartments per floor. So if that's the case, and I wanted to have a Boolean variable that tells me whether if a particular apartment has mail or not, then the only way that I have, if I only know how to write one-dimensional arrays, it could be something like declaring, well, let me create an array of Booleans, and I'm going to call this has mail, and then for floor, and this is going to be a new array of Booleans and I'm going to use here apartments per floor, which is how many apartments are on my floor. But if I do this, I could only store a list of booleans for one particular floor. So for example, the first floor, which means that I would probably have to give this a number, has floor number 0 male, and then I can store each one per. And then if I wanted to do every floor, I would have to end up doing something like this. I would have to end up handwriting manually one array of Boolean values for each one of the floors so that I could keep each one of the apartments on that floor in memory. You can probably imagine how this is terrible practice, because anything that means hard coding is a terrible thing, and also because this is not flexible. If for any reason the number of floors in my building would change, which is not a common situation, but I don't know, maybe they make an extension, or maybe I would just want to use this code for a different building that has more floors. This is just not sustainable. And also I can just not iterate with for loop over all these different variables. So the solution is, in this case, instead of using one-dimensional arrays, we can use, which is what we know how to do from previous videos, we can use multi-dimensional arrays. Multi-dimensional arrays are arrays that have more than one dimension, aka they can store data across a list, and then inside of that list, they contain another list, if you will. The idea is that, for example, in this example, I'm going to teach you how to do 2D arrays, so arrays that have 2 dimensions, and they're multidimensional because one of the conditions for this particular code that I'm going to write here is that those 2 dimensions are constant in size. So for example, if we have 9 floors, the condition for the code that I'm going to be writing today is that each one of those floors has the same amount of apartments. So that if we were to imagine this in an abstract way, my 2-dimensional array would have the same number of columns and the same number of rows in every dimension. It's like a square matrix of values, if you will. Okay? So how do we do that? It's actually pretty simple. The way we do that is we say, for example, let me store in an array, but I'm going, instead of just using the simple square brackets, I'm going to add a comma inside of the square bracket to denote that this type of array is not just one dimension, it's 2 dimensions. And then I'm going to call this variable as male. And then what I'm going to do is I'm going to create a new array, a new 2-dimensional array, but just like with any array, when I create this array, I have to specify what the dimensions of each one, how much room does this array have for data. So in the first dimension, I'm going to use how many floors my building has. So for example, I'm going to use the number floors here, all right? And then here, I'm going to say apartments per floor. So my building has 5 apartments per floor. So now my array, my 2-dimensional array, has 7 spots in the first dimension and then has 5 spots in the second dimension. Therefore, once we have that, what I can do is, and let me create another one. I'm going to create a string because I'm going to just keep the name in memory for each one of these apartments. So I'm going to create another array called apartments, and it's going to be a new string array 2-dimensional, which is going to have floors in 1 dimension and apartments per floor. So the same size as my Boolean array. And then, because it's a 2-dimensional array, the best way to navigate and to populate these 2 arrays is going to be with a set of 2 nested for loops, which we have also seen in previous videos in this playlist. So I'm going to create a for loop, which is going to be the first dimension. I is going to be the floors. So I is going to start at 0, is going to be less than the amount of floors we have, and then is going to increase by 1 unit. And then inside, I'm going to create another for loop that is going to iterate over the dimension of the apartments. So for int j, which is going to be the second one, equals 0, j is less than apartments per floor, and j is going to increment in units of 1. So now I have 2 for loops that iterate over each one of the floors, and then in the floors, each one of the apartments. Okay, I like the architectural metaphor of this example actually a lot. It's very visual to see, right? And then with this now, what I'm going to do is I'm going to populate data into these arrays. So for apartments, I'm just going to create a string name for this apartment. So that's going to be, for example, apartment, and I'm going to use string literals, which we have also seen in previous videos. So the name of the apartment is going to be the number of the floor, a 0, and the number of the apartment. So that's going to be apartment, apartment, then the variable, the variable I, which is which floor am I in, and then maybe instead of a 0, I'm going to use a dash, for example. And then here I'm going to do the J, which is the number of the apartment that I am in. And I'm going to put a semicolon to stop here. I have an error. This is telling me that I cannot convert from string to a string multidimensional array, and that is because I made an error, which is that I'm trying to assign a string to the whole array. But I need to, as you know already, I need to point to which position in my array I want to save this string to. So I forgot this, so I'm just going to open and close curly brackets, square brackets, and then it's going to be I for the first dimension, the floor that I'm in, and J for the second dimension, the apartment that I am in. And now for has male, I'm going to do the same thing. I'm going to open and close square brackets, I floors for the first dimension, J apartments for the second dimension, and I'm going to initialize them to false. Okay? Absolutely fine. So all the apartments are going to start with a false, with no male. Then let me see if this code runs. This code runs, it does absolutely nothing. Right now, it only creates those 2 arrays in memory. Now I can finish that. And then what I'm going to do is I'm going to imagine that my code, once this is the initialization of my code, then I have some other thing connected to the mail delivery, whatever, which changes the value of the trues and false in my array. So for example, some algorithm that tracks mail and updates as mail. Okay, so this is a placeholder for some algorithm that figures out how to change that. And then the way that would work is that basically that algorithm would go to the array and say, for example, in floor number 2, apartment number 3, there is mail. So I'm going to change that to true. And then in some other apartment, for example, in apartment 6 and number 0, then that one is also going to have some mail. So you can see that floor number 6, remember we start counting by 0, floor number 2, and then here apartment number 3 and apartment number 0. Those 2 are going to have mail. And then I'm just going to check mail in all apartments. So I'm just going to print to the console a full list of all the apartments and whether if they have mail or not. How am I going to do that? I'm going to do also with a for loop, with a nested for loop, where I'm going to go over all the apartments, and I'm just going to print to the console a message saying whether if apartment blah 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 has or not mail. So for example, I'm going to write here the name of the apartment, so apartments I, J, and then I'm going to write has mail. And then here I'm going to write the value of the Boolean array that I just created. I'm going to run this code and then let's see what happens. So it looks like, sorry. It looks like if I extend this window and I zoom in, you can see that basically none of the apartment has mail except for apartment in position 2, 3, which has mail, and apartment in floor number 6, apartment 0, which is true. This is a very computational building. Floors and apartments start with number 0, which is great. Okay. So, that's pretty much it. So remember that in this example, we have used 2 dimensions for the arrays. So that's why we started this with a square bracket, and only one single comma inside, which means 2 dimensions. But if, depending on the use that we have, we may actually need more than 2 dimensions. Imagine we are, for example, designing a very complex building that has floors, it has sections within the floor, and then it has apartment with each one of these sections. So maybe we need 3-dimensional arrays in that case. Or maybe we're trying to represent a 3-dimensional space of voxels, and then those voxels can be represented with a 3-dimensional array. Who knows? Okay. The only condition is that if we write arrays this way, in a multi-dimensional way, is that the dimensions in each one of the directions have to have the same amount of elements. That's just it. Okay. So multi-dimensional arrays work in 2D, 3D, 4D, 5D, whatever you need. It's up to you. All right. Wonderful. Thank you very much. If you like this video, please hit the like button, maybe subscribe to the channel and show some gratitude to the work that we do. And then hopefully see you in some other video on this playlist. Thank you. Alrighty. Okie dokie. So that was 2D arrays. Thanks a lot for the example, Victor. That was a really good one. I'll be right back. 1 minute. We're still not done. 1 minute. Alrighty. Now, what was the last thing I wanted to do? Oh, functions with the out parameter or with the reference parameter. Oh my god. Okay, so how are we going to do that? C# out parameter, the out parameter modifier. Yeah. Because arguments to be passed by a reference. Okay. So basically, what I would like to do is I would like to write what I would like to do is I would like to write an example of a function that returns a bunch of things, and instead of doing that from the return type like void or string or integer, it uses the out parameter. And I would like to find an example of why that is useful, especially if we return things that have different types. Like I want to return a double and I want to then also return a string. How could I do that? What is a good example of a function that returns multiple things without getting into classes, etc., etc.? What could be a good example of that? Say we write a function to compare two numbers. Maybe what we return is their difference as an integer, and maybe like a text. Or maybe an operation that could return an error message because it could fail. What could that be? Any ideas for a simple function or a simple operation that that should return multiple things, especially with different types like double and boolean and string and that kind of stuff? What do you think? I think comparing two numbers could be useful. Or for example, taking if we compare two numbers, we can return a variable which is A greater than B, true or false. We can return a number that is their difference, and we can return a string that is A blah 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 is greater than blah blah blah. And then what would be the main return type? The void, the when we compare two numbers. Or for example, we could write a division function that returns the result, or returns true or false, if it's possible. Because for example, if we divide by 0, that should not be possible. So if we divide by 0, that operation should not be possible. And so what is this? So this is going to be 63 and so if I do this and if console read key, and then what if I double 4 equals 4 divided by 0? Yeah, division by constant 0. What if I say double division, double A, double B, and then return A divided by B. And this is going to be division A plus B. Oops, sorry, 4 and 0. And then What? Oh. And cancel. Right line. Then ooh. And this returns infinite. I did not know C# did infinite. Interesting. What if I do 0 divided by 0? Huh? What does this return? Not a number. It's not even infinite. Thus, minus infinite. Interesting. And and then I'm kind of exploring here right now. I did not know that C# had infinite as a symbol, really. So it still lets me do operations? Kind of interesting. Interesting. So maybe division is not a good example, maybe comparing two numbers. I wonder if division is then the alright example, or maybe it should just be, well, I'm gonna have to go very soon. Maybe division is just let's just use compare. It's fine. So compare double A divided out boolean is greater out integer difference out string yeah, we can do this, and then this is going to be if A is greater than B, message is going to be equal to A is greater than B, for example. The greater is false, and then is greater equals true, and then else if A is less than B, then message is smaller, and then else is equal to B, and then difference is going to be equal to A minus B, whatever. Oops, double. Okay, and then I can define double greater double difference, and then string message. And then, for example, here I can say compare number 10 and number 4. And then out is going to be greater. And dub out is going to be difference. And out is going to be message. And then here I can console write line greater, console write line difference, and console write line message. And I can run this thing through, and then here difference is, and then is A greater than B, and then I can run this. Okay, and through the difference is 6. Okay. I think this could be a good example. And I'm just gonna copy paste it here. Okay. I'm gonna have to go very soon. So can I record this real fast? Do I want to record this real fast? Not necessarily, but it is what it is. Okay. Okay, so let's just do this. Hi, this is Jose Luis, and in this video I'm going to teach you how to write functions that can return multiple values at the same time and with different types inside of C#. If you may remember from previous videos where we learned how to write functions that return values, they take arguments, they crunch some values, some data, and then they return something back. What we learned was that these functions typically only returned one single unit of data or an array of them, and typically of the same type. So, for example, let's say I'm going to start over. I'm going to start from an example that is going to be compare, and then and for example, double A, double B, and then return A is greater than B. And then here, bool is greater, compare, okay, 10 and 4. And here I'm going to, yeah, so I'm going to start from here. I'm actually going to start from here, yes. Okay. Hi, This is Jose Luis, and in this video, I'm going to teach you how to write functions in C# that return multiple values and with different types. Because if you remember from our previous videos where we saw how to learn, okay, starting over. Hi, my name is Jose Luis, and in this video I would like to teach you how to write functions in C# that can return multiple values and with different types. Because if you remember from previous videos when we learned how to write functions, you would remember that functions always have a return type, which means that this is the type of value that they can return, and it's typically only this one type of value. We can return multiple units of data by returning an array of values, but if we want to return different things, it's not so simple, it's not so straightforward. Like for example, here I have an example that I've written where I created a function that compares two numbers, okay? And then it returns a Boolean value on whether if A, the first number, is greater than the second number, B. And then here I can store that into a variable because that's my return type, and then I can just print that to the console. So for example, here, is A greater than B? Yes, it's true. Okay. So this is great. It's just that if what I'm doing is writing a function that compares two numbers, there are many ways of comparing two numbers and many metrics that you can use for comparing those two numbers. So I may want to take the chance that I have this function that takes two numbers and then apply multiple things here to make sure that that I can return different things in this code. So for example, I may want to return the difference between these two numbers. So in this case, it would be the number +6. Or I may want to return a message, like a string message that says, well, 10 is greater than 4 as a string, you know, that I can use, for example, to print to the console or something else. So I probably don't want to write multiple functions that do similar things but return different types. It's kind of a bit of an overload, a little of, not overload, that's a technical word that I don't want to use with functions here. So it's probably like a lot to do. So there is a trick that we can use in C#, which is we can use what's called the out parameter modifier for for arguments in a function. What that means is that what I can do is that for a particular function, I can specify that some of the arguments that are going to come into the function is going to write values in those arguments, and then it's going to return, not really return, it's not the right word here, but it's going to be, let's say that the values that are going to be written in that function are going to stay as part of the variable that was passed as an argument. And therefore, implicitly, whatever changes we make to the input to the argument are going to stay in that argument after that. This was a really complicated way of saying, I can write here a variable, so for example, difference, that is going to come here. I can change the value of that variable, and then that value will stay in my main program as an argument that I have passed to the function. This is because of how functions work in C#, because elements and value can be passed by reference or by value, which I'm actually not sure at this point if we have covered that topic in the videos. I need to take a look at that. But the outcome is that. So let me show you how that works. So for example, let's say that here I'm going to add another argument to the function. This is going to be a double, and I'm going to call this difference. So here I'm going to store the numerical difference between the two values. And then, but what I'm going to do is that I'm going to say that this is going to be a parameter with the out modifier. What that means is that if I pass a variable here as an argument, I'm going to change that value and I'm going to return it back to the function. So for example, let's say that I add this to the out parameter. And then inside of the function, I say, Well, so difference, which is already a variable inside of my function, difference is going to take now the value of a minus b. All right? And then here, what I'm going to do is I'm going to define a variable that I'm going to call, for example, diff, and then I'm going to pass that variable as an argument to the function and with the out modifier on it. What? And then if I now, for example, go ahead and here I say, can I console write line that the difference is this value, the value of diff? Let's see what happens. If I run this code, you can see that my output is difference is the number 6. Wait, but I have never defined the number 6 here as the value of the double, right? Okay, so let's take a mental journey, if we will, about what has happened here. Computer starts, we create a variable that has no value, so the default value is 0. And then what we do is we call this function with the two hard-coded numbers. And then we take this variable, a placeholder, we pass it as an argument to the function, and we say, with the out modifier, I say, I want to be able, if you make changes to this, I want to be able to keep those changes here in my main code. All right? Then the computer jumps to this function. It passes in the number 10 here, the number 4 here, and here as an argument, it passes this empty variable that we're using as a placeholder. This empty variable inside of the function gets a new value, which is 10 minus 4. And that value stays because of the out parameter. We do a greater than b, whatever. So this function finishes executing. The return here, true, gets stored in this variable. But also, the number 6 resulting of this calculation stays in this argument, which in turn goes back to the main code, which in turn keeps the number 6 inside of this variable. And therefore, from here on, this has the value of greater is true, but then here, the value of diff now has the value of number 6, which was created when the function was called and when that number was stored in one of the arguments that we passed. That we passed as a way of collecting data back on the main code. Was that clear? Did I make a good point there? Okay, let's see another example. Let's say that I want to have a string with a message that tells me exactly what the comparison between those two is. So for example, here, out string message, for example. And then here, I'm going to paste a bunch of code that we already are familiar with. So for example, if A is greater than B, then the message is A is greater than B. Otherwise, A is smaller than B. Otherwise, A is equal to B. And I'm storing each one of these 3 messages in the variable, in the argument that has the out modifier. And now here, what I can do is I can create an empty variable before, and then pass that variable to the function as a placeholder to collect the data that has been generated inside of the function. Okay, it's like a net. Like you throw the net, you pick up stuff that is happening inside of the function. And then, after that, I can print to the console the message, right? And if I run this code, you can see that, yes, 10 is greater than 4. The difference is number 6. And now, for example, I'm going to say number 3. And then, yeah, is A greater than B? No. 3 is smaller than 4. The difference is minus 1. Okay? Alrighty. I think that was it, except for one thing. This idea of defining a variable beforehand and then filling it in with data that has been generated in the function is a very common way of calling and managing this function, because these variables might be variables that we are working with in the function or in our main program, and that they keep changing value when we call compare multiple times, whatever. So maybe this variable was living and was created somewhere far away, And now we are just populating it with data using this function. But if we are creating these two variables explicitly only for this one time that we're going to call compare here, then we can shorthand this, and then we can create that variable on the spot. This is just a shortcut that I'm touching you here. We can avoid creating them beforehand, and we can just create them on the spot by saying, can you keep the output of this argument into this new function, this new variable that I just created here in line, by writing the word double here? And can you do the same thing here? Can I create a new variable called message on the spot in line so that I can store that value and then I can use it later? These two things are the same thing. They're just shortcuts of one another. So this is basically a shortcut. So this is one way of doing it, and this will be the shortcut, the inline shortcut for the same idea. Okay. All right. So out modifiers for arguments are very useful if you have functions that you know want to return multiple things. So for example, this function is returning a Boolean to represent whether if one number is greater than the other, but it's also giving us additional information. So the difference between them and this message that we can use. Okay, this is a fairly common pattern in C#. You will see it in many places, and it's a very popular one for returning multiple objects. Okay. Alrighty, thank you very much. If you liked this content, maybe you want to consider liking this video, subscribing to the channel, and all those things that are commonplace these days in YouTube. And hopefully see you in some other video on this playlist or some other video in the channel. Thanks a lot. Bye bye. All right. Okay. Well, that was 3 nice videos for the morning. I'm very happy about those, actually. Yeah, I think I am. Yeah. Cool. Cell phone to grasshopper. I am actually not sure how I would write that from scratch. That's a pretty good one. I know I would definitely use Hologram for that. But I don't know how I would need to take a look at how to do that from scratch. Mobile, I have to say, I'm always like about mobile, just because it's tedious, has a lot of things you need to take care of. Then you need to write it for Android and then for iPhone. And I have no no Apple product whatsoever. I don't own a single Apple product thing. And then if you don't want to do that, you want to maybe use React Mobile, but then you still need to have an iPhone to try things. It's kind of like, it's a lot. So I typically try to stay away from native mobile stuff and just do web stuff that works well on mobile. All right. I have 2 minutes for questions or Q&A or social or whatever. Arasto, I'll take a look at that message later, okay? Because I have to go. I have a meeting in 5 minutes. As you may know, I got elected this year as part of the board of directors for the Acadia organization, the Association for Computer-Aided Design and Architecture. And we have meetings. We're very actively working on preparing what the conference and the workshops are going to look like this year. So I have a meeting with my colleagues right now to take a look at that. Any questions? Thank you, Smoke C. I like that. Make sure you check all our other videos in the channel, okay? Alrighty, and I think with that, I'm gonna call it a day. Arasto, thanks a lot. If you can give me a hand with the video chopping and editing, that would be great. Otherwise, it's fine. Just let me know, okay? Bye-bye. Thanks, everyone. Andres, everyone else. Have a good weekend. See you next Friday again, all right? I'm back on track. See you next Friday. Bye bye.